Every other day, let's hit it hard. Multiplicities and polynomial functions. So, I'm just going to cough through the entire class, so just, I apologize in advance. The graphs of several polynomial functions of the form y equals x minus 2 to the n, so n is 1, x minus 2 to the 1, x minus 2 squared, cubed, to the power of 4, to the power of 5, to the power of 6. Now we notice, and you can say, well, there's some commonalities here, right? Like there's something going on, especially when x is equal to 2. So the binomial x minus 2 is a factor of each of the, so a factor it's a 0, right? It's where it's the value of x that makes it 0, you can turn that into the factor. The x-intercept of each of these functions, so what's the x-intercept? 2. There's a relationship between the exponent on the factor and the shape of the graph. Use this relationship to predict the following. So if y equals x minus 2 to the power of 7 was graphed, what would it be similar to? Which of these guys? Either the cubed or the power of 5, right? And what do you think would happen? I mean, it would just kind of flatten out a little bit more along the axis, right? But it's not, it's actually only crossing the axis at that one point. It's just really close to it. All right, so it looked like the graph of y equals x minus 2 cubed, or y equals x minus 2 to the 5th. If y equals x minus 2 to the 8th was graphed, then it would be similar to squared to the 4 or to the 6. Squared, 4, 6. For y equals x minus a to the n, describe the behavior of the graph at the x-intercept if the exponent n is even. Okay, so what's going to happen if the exponent is even? For x minus a to the power of n, what's it going to have? So what's the graph going to do? It's good. I call it touch and go, right? It's going to touch and go, but it comes down, it's tangent to the x-axis at the point A, right? So the graph will be tangent to the x-axis, meaning it's just going to touch it. It's not going to cut through, right? It won't drop below. So the graph is tangent to the x-axis. Right? At what point? Well, at the point x equals a. Let's just say when x is equal to a. And so tangent just means that it touches but does not cross. So it touches, so it'll touch the x-axis, touches the x-axis, but does not cross. So I just like to say touch and go, right? It's going to hit it and then turn around. For y equals x minus a to the n, describe the behavior at the x-intercept if the exponent is odd but not 1. So not 1, but odd. Then what do we have going on? And you're not going to, but what's it doing? Does it go through the axis? Yeah. At the point when x is equal to a. And here's where it changes direction, right? So it does this, and then it does this. We call that a change in concavity. Okay, so it goes through the axis, so the graph goes through the axis. Goes through the x-axis with a change in concavity. And I'll tell you what that means in a second. So if you look at this graph, you could say, if I sort of kept going like this, then I'd have this graph, which is concave down, right? Concave, like making a cave, right? Or concave lens. If any of you have done physics, optics stuff. So this part of the graph is concave down, And this part of the graph is concave up, so it's a change in concavity, right? A change in direction. If you think if I'm driving along the graph, I'm actually have to make a steering input, right? I'm going to have this thing curving a bit, then I'm going to have to straighten the wheel out and turn it the other way, right? So there's turning happening there. We call that a change in concavity. Describe the behavior of the graph as intercept. You can read that. What does it do? So what's it do right here? Passes straight through, right? So straight through. Not changing direction, right? There's no curving going on, it's just a straight line, it's just going straight through. So when the degree is 1, the line is just going to go straight through the x-axis at x equals a. So the line passes straight through the x-axis. Right, when the value of x is equal to a. The graph of a here's a polynomial function. What are the x-intercepts of this graph? So where does it intersect the x-axis? X equals -3 and x equals 1. So what are the factors that correspond to that? What's a factor that corresponds to x equals -3? X plus 3, right? And what's a factor that corresponds to x equals 1? Okay, because what do you know? When it intercepts, what's the y value? 0. So we want, if x is -3, then we know that x plus 3 will be equal to 0. This is the root or the intercept. This is the corresponding factor. Okay, and then same, if x is equal to 1, then x minus 1 gives me that value of 0. The shape of the graph at x equals -3 indicates what kind of exponent? Even or odd? Even, right? Touch and go. It's tangent to the axis, so an even exponent on the factor. So at this point, when x is -3, the factor is x plus 3. So that means that the factor x plus 3 must be of even degree, because the behavior is touch and go, right? Tangent to the axis, it's turning around. The shape of the graph at x equals 1 indicates an odd exponent on the factor, okay? It's odd, but what isn't it? It's not 1, because if it were 1, what would it be doing? Go straight through. So we know, hey, it's not going straight through. It's changing concavity, right? There's a change in direction there. So it's odd, but it's not 1. And that's on the factor, right? So the 0 is 1, and the factor is x minus 1. The equation of the polynomial function could be written. So when we do this, we look for the lowest. So it's y equals x plus 3 to the power of what? 2. And it's x minus 1 to the power of 3. Okay, if it was going straight through here, then we'd say, oh, that's 1, right? If it does this, then we say it's odd, but it's not 1, so its lowest value is 3. If it's doing this, we say it's even, and its lowest possible value is 2. If square and oval, or ellipse, represent the smallest possible natural numbers, okay, so we did that. The values -3 and 1 are also called the zeros of the polynomial function, because when each value is substituted into this, you put a -3 in here, the resulting y value is 0. So given the function, right, an equation for the function, then those values are the zeros, right? They're the value of x that makes y equal to 0. They are the x-intercepts of the graph, and they're the roots of the equation, I think. So it can be said that this function shown has 2 zeros. Right? There's 2 places where the y value will be 0, and we would say we have 2 zeros. We have x is equal to -3, which has a multiplicity of 2. Multiplicity is simply the degree on that, right? So if I say multiplicity of 2, you say, oh, it's going to look like this. If I say multiplicity of 1, you're going to say, cut straight through. If I say multiplicity of 3, you're going to say, I got a turning point, right? Got to draw that. And x equals 1, which is a multiplicity of 3. The degree of the polynomial can be determined by adding the multiplicities of all its zeros. So the above function is of degree 5. And if you look back at your other stuff, you'll say, oh yeah, I've got, well, 1 turning point, 2 turning point, well, that's sort of a thing, you know. But I know this is odd because it goes from down in Q3 and up in Q1. Right? Makes it of odd degree. Just putting that together with the previous worksheet. For each of the following polynomial functions, state their zeros and their respective multiplicities. Circle whether the multiplicity is even or odd. So for each one, we'll say it's even or it's odd. Determine the y-intercept. That means you got to show some work to get the y-intercept, right? And without using a graphing calculator, sketch a possible graph for each of the functions, labeling all intercepts. Okay, so perfect, nice little test question. Right? We could ask that. So give me a sketch, blah, blah, blah. It's got to have all this stuff. Okay, so we've got a 0. What's the 0 for this guy? Okay, so 1/2. Everybody see that? So all you do is you set 2x minus 1 equal to 0, and then you solve and you get x equals 1/2. Now, it's with a multiplicity of what? 1. And is that even or odd? Okay, then we have a 0 when x is equal to -3 with a multiplicity of 2, which is even. And we have x equals 4 with a multiplicity of, which is, and so we've got 3, 2, 1, giving us a degree of 6, right? 1 plus 2 plus 3 is 6. The sign of the leading coefficient, so if I were to expand that, my leading coefficient would have a sign, the sign of leading coefficient would be positive. So if it's degree 6 and it's positive, then we know something, right? It's going up in Q2, up in Q4. The y-intercept, okay, that which has to be determined. How do you get the y-intercept? You set x equal to 0. So let's just pop up here and say, what's f of 0, which will be 2 times 0 minus 1, sorry, just to the power of 1. 2 times 0 minus 1. 0, clean, 0 plus 3 squared, and 0 minus 4 cubed. So 2 times 0 minus 1 is -1. 0 plus 3 quantity squared is 9. And 0 minus 4 cubed is -64. So what do we got? 10 times 64 is 640, and then we'll subtract 4, 636, and then we'll subtract 6, and 576. Is it positive or negative? Positive, okay. Now you can, of course, always use a calculator, right? So it's positive 576. All right, so go down here. The y-intercept is 576. So if you're going to graph that on your calculator, you're going to have to set a window that goes, you know, at least as high as 576. End behavior. The graph extends blank in quadrant blank and blank in quadrant blank. So up or down and where, and up or down and where. Positive leading coefficient, even degree. Up in 2. Nope. And up in 1. Okay. Just think x squared. There's y equals x squared, right? Think negative x squared. If it's even, just think x squared, negative x squared. If it's odd, just think y equals x, y equals negative x. You'll get your M behaviors. Right? Like y equals x, down in 3. So if it's odd and it's a positive leading coefficient, right? Y equals x, I've got this. And if it's y equals negative x, so if it's odd and it's a negative leading, you've got this. Doesn't matter what the degree is. If it's 7, then you got all kinds of other stuff going on. but the end behavior is the same as degree 1, that is positive or negative. All right, so now we want to put it all together. We've got a negative 3, so let's get the scale on here. We've got to go to positive 4. We need a 576. So we've got an x, so we got at 1/2, negative 3, and positive 4. It's of degree 6. We know it opens up, so it's coming from up here. It's going to hit this, which is negative 3, which has a multiplicity of 2. So what's it going to do at this point? Pass straight through, have a changing concavity, or touch and go? Touch and go. So it's going to come down here, head back up. Okay, now it's heading up. Where's it going to go next? It's got to go through the 576, right? Because there's no other zeros here. So it heads up, hits the 576. Now it's got to turn around. It's going to come down. That's actually kind of bad. So let's see. Comes down, and at 1/2, what does it do? So you get cut straight through, touch and go, or change the concavity. Okay, at 1/2, degree 1 is going to cut straight through. Okay, so it cuts straight through. Now at some point then it turns around again, because it's got to come up here. And we know it's got to end up going up. So it's degree 3, then it's just going to do that, right? So we look at this and say, oh, even degree, right? Degree 2, it's cutting straight through, that's degree 1, and changing concavity, that's degree 3. It's degree 6, and it's positive, so it opens up in both quadrants 2 and 1, and it's got a y-intercept here. That's the only way we can draw, right? Like once you know I'm starting here and I'm going to come down, this is even, then I have to go through this, then what? Oh, I better turn pretty quickly, and I got to drop down, and away you go. Yes?
Is there a way to find out where exactly you're going to drop it? In quadrant 4?
Yeah. Stay tuned for the next math course. Yeah, in calculus we do that. Oh, you can just graph it, right? You can graph it. Eventually, like your graph has to go. I take it up to about 1,000 probably, right? So I can see the 576 pretty easily, and then see, oh, there's a turning. Because I know after 576, I don't know how much further it climbs, but I know it's going to drop pretty steeply. And how far down does it go? If I went to negative 100 and I could just see like 2 lines, but then I need to expand. So you'd have to play with the window and all of that. But next math course you can learn. Oh, and then. Okay, the partial graph of a polynomial function, right? So what do we just do? Given an equation, we figured out the characteristics from the equation, we drew the graph. Now, given a graph, or partial graph, assuming the minimum multiplicity from the graph, we're going to say stuff, right? So I've got a 0 when x is equal to negative 2 with the multiplicity of, assuming the minimum, 2, right? Turning, so it's got to be even. We've got a 0 at, with the multiplicity of, so 0 when x equals 1 with the multiplicity of 3. We have another 0 at 2.5, which we of course will write as 5/2, with a multiplicity of 1. I write that as 5/2 because I can very easily work that back to the factor. If I write x minus 2, if I write 2.5, then my factor becomes x minus 2.5, which is not an acceptable factor, right? You can't have a decimal there. But I can write that as 2x minus 5 as the factor. Okay, now, so they want the equation in factored form, right? So if we know that x equals negative 2, let's do the factors over here. If x is equal to negative 2, what's the factor? X plus 2. If x is equal to 1, what's the factor? X minus 1. if x is equal to 5 halves, what's the factor? That takes a little bit of work, right? So what's the work that goes with that? Just start with this. X is equal to 5 over 2. 2x is equal to 5. 2x minus 5 is equal to 0. My factor is 2x minus 5. Okay. So your shortcut is stick this number in front of the x, and if this is positive, change the sign, right? Put this number in front of the x, put this number at the end, and put the opposite sign to this in the middle, because what's going to happen? You're going to put this number in front of the x. You're going to move this number over, and when you do, it's going to change signs. So if that was negative 5 halves, this would move over, become positive 5. If it's positive 5, moves over, becomes negative 5.
How did you exactly know it was multiplicity? By 3.
Okay, minimum multiplicity. This is odd because it's going through. It's not going straight through, so it can't be 1. It's odd, so it can't be 2. It's odd, and it's not 1. 3.
It has to be the minimum.
Only if we go with this circled, underlined. How well do you read the questions on the test? I get that, right? Yeah, RTQ, 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 right? When you get it back to look at it, you realize, if only I had read this, I would have got that half mark, right? Like there's a lot of half marks missing, mainly because you just didn't read it. Write it in the form q of x, y equals q of x, right? What does that mean? Do all the stuff with y, and then my very last line, instead of y, I write q of x. Right, we did it with a lot of g of x's. I asked you to do it with q of x, you give me y equals. I asked you to do it with q of x, you stick the p there and the q on the other side. But no. It was p of x to begin with. It's p of x has to have the modifications done to it, right? So, read the question. Intervals where p of x is positive. Okay, when is it above the x-axis? Between 1 and 5 halves. So how do we say that? Say 1 to 5 halves. Why am I using parentheses and not square brackets? It doesn't include 1, because what happens at 1? Then it's 0. Is 0 positive? Is 0 negative? No. So if it's positive, it can't include 1 or 5 halves. When is it negative? Well, here, but not here. And then here, but not here. And then here. Okay, so how do we say up to here, but not there? So we say from negative infinity up to negative 2, but not including negative 2, because then it would be 0. And then we take that and we put it together with from where to where? From negative 2 until I get to 1. Right? Where am I negative? Well, okay, from here to here, but not including the endpoints, because that's where it's 0. And then I put that together with from 5 halves to infinity, right? And it's parentheses everywhere because none of these are included, right? Because we never include infinity. We don't include negative 2, right? So this is just basically saying, when you look at this, you say not negative 2 and not at, wait a sec. So I go to negative 2 to 1. Yeah, that's fine. And then from here, right? Like these two aren't together because it's not negative in there.
So for the third bracket, would it just be normal infinity, not negative infinity, even though it's going downward?
Yeah, because it's the x values we're talking about, and they're going this way.
Oh,
right? It's not the y. It's the x's. Where do the x's go? If x is from 5 halves up, so it's positive infinity. Right? Just as above 5 halves. Okay, anything above 5 halves. I couldn't throw a negative infinity there because it really has to be on the left of my interval. Right? So what I'm doing is I'm going from negative infinity to positive infinity, cutting out the zeros and the places where it's positive. So I'm cutting out any of the zero, and I'm cutting out this interval, right? Like this would fit nicely in there, right? Oh, from 1 to 5 half, but no, that's where it's positive. What's the sign of the leading coefficient? Or what degree is this thing? Degree 6, so it has what kind of a leading coefficient? Degree 6, and it opens down? Negative. Watch out, or your mark will be neither positive nor negative. What's the equation of the polynomial function in factored form? Okay. Now, we do have a y-intercept, right? Which is negative 20. So when we write this, we're going to say, I know it's of degree 6. I know that it has a negative leading coefficient. I know what my factors are. I wrote them, right? So we've got what? X plus 2. So let's write this. We got y equals, we got x plus 2 squared. We've got x minus 1 cubed. We've got 2x minus 5 to the 1. The 1. Okay, what's this y-intercept? So we've got 4, negative 4, and then positive 20. Is that positive 20? No, that should be negative 20. Okay, so that's 4. That'll be negative 1, negative 4. Okay, oh, but we know the leading coefficient is negative, right? So we're going to get our 20, but we're getting negative 20, so we're going to have to toss a negative in front, because we know it has a negative leading coefficient, but we don't have to adjust the 20. Right? If that was negative 40, what would we throw in front? Negative 2, right, to make it negative 40. Okay, it's negative 20, I'm getting positive 20. Wait, it opens down, we know it's a negative, right, and it's just negative 1. So we don't have to work the a value. If I was working this more general, I'd put an a in front, and then I'd throw the negative 20 in here, and the 0 in here, and then I'd work out what's a. Okay, in this case, no, we can see. We'll just write that up there. Multiplying the equation of polynomial function by a constant. Ooh, stretches. Ooh, transformations. You're not going to get away from them. What's going to happen, though, is in a month you're going to come back, look at that test, and go, how did I get that wrong? This is so easy, right? I've talked to people before. I talked to guys, I had them in 31 last year. He said, I started out, I got like 56 on the first quiz. It says, and then a month later I looked at it, it's like, how did I get any of this wrong? It's so easy, right? Because the reason is we're going to be doing a lot more with all the transformations that by the time you look back at it, it's like, this is so obvious, right? Like, what was I thinking? Hopefully you put what you wrote down there so you can say, I was thinking this. Well, that was wrong. I got a lot of stuff where people write, it's a horizontal stretch by a factor of 3, so I'm going to write a 3x there. No, that's a horizontal stretch by a factor of 3. Right? Like, you have to know those 6 transformations, right? Like, just off by heart. Vertical stretch by a factor of 2. Instead of y, I'll write a half y. Okay. The partial graph of y equals x plus 3 times x plus 1 times x minus 2 is shown. Use your transformation skills to accurately sketch the graph of y equals 2 times x plus 3 times x plus 2 times x whatever, and 1/2. And negative 1/2 on the same grid. Use different colors for each graph and label each function with its equation. All right, so take a moment to do that. Right, in the video also, boom, look, they're all 3 there. Okay, and here they are. Does anybody object to any of these? Did I mess up anything? Seeing none. I'll tell you when you mess up if you tell me when I mess up. Okay. So, I think those are good. The nice multicolor effects on okay, given that, complete the following statements. Multiplying a polynomial function by a constant causes a, you can use your words here, vertical stretch. By the way, on the test, if you have space, use the words vertical stretch. If you don't, if it's a big table or a little table where there's a room, then you can go VS, right? But otherwise, try and use vertical stretch. What I'll do is I'll allow you this. I'm going to ask you to write the words vertical stretch. I will no longer ask for you to write. I certify you as stretching experts. You no longer have to write about the x-axis or about the y-axis with your stretches. So you can simply say vertical stretch by a factor of 2. I think it's ingrained in you by now, other than one person actually who missed the variables up, but I didn't take any marks off for that because I said If I'm going to accept vertical stretch by 2, then I'll accept that. If the constant is negative, then there's also a reflection in the x-axis or the line. Because that's where the invariant points are. Where are they? They're on the x-axis. Why? Because it's the line y equals 0. And what happens when y is 0? Well, you can't stretch away from that line, right? Because you're on the line. So the invariant points are the, what will we call them then? If they're on the x-axis, they are the x-intercepts. Okay, because under a stretch or a reflection, they are not going to go anywhere. Right? So the x-intercepts are on the x-axis, they're on the line y equals 0, right? They are on the line of reflection. Algebraically determined, which means what? You got to show work, it has to be algebraic work. Right? It's not like, look, I drew a graph, and no, doesn't cut it. Algebraically determine the factored form of the equation of each polynomial function. It is quartic, which is degree what? Degree 4. There are 4 zeros, so they must all be of multiplicity. They're all multiplicity 2, all multiplicity 3. Some are 1, some are 2, some are 3. You have 4 of them. Their multiplicities have to add up to 4. There are 4 of them. They're all multiplicity 1, right? Okay. So then we know this is going to look like, well, so we need to get from the zeros, we need to get the factors, right? So y equals. Now, we don't know the leading term, right? But we do know it goes through a point, so we're just going to stick a value a there, right? And then we're going to say, okay, x plus 2. X minus 1. Hang on, I'm slow. 3x minus 1. And give yourself some room. So x equals negative 3 halves. 2x equals negative 3. Okay, so 2x plus 3 is equal to 0. Okay? But that's how you do it, right? Like if you're doing this, you want to avoid it, then it's 2 lines. Write out 2 lines, right? Is 2 lines worth a half a mark? Yes, it is. Just not going to answer that. 2 lines is worth half a mark. All right, what do we know? And what am I going to write now? Substitute 2 in for x, right? 2 plus 2. 2 minus 1. 3 times 2 minus 1. 2 times 2 plus 3. Okay, so negative 70 is equal to a. So we got a 4 and a 1 and a what? And okay, so we'll just evaluate each of those guys, right? So 4 times 5 is 20 times 7 is 140. So then negative 70 is equal to 140a. Now at this point somebody's going to write a negative 2 and get it wrong. Okay? And then they'll get it back and they'll go, oh, how did I do that? Okay, so then a is equal to negative 70 over 140. A is equal to negative 1/2. And what did it ask? Determine the factored form. So y is equal to negative 1/2 x plus 2, x minus 1, 3x minus 1, 2x plus 3. That's your factored form. You finish the test early, go graph it, plug in an x value of negative 2, it should say 70. Sorry. Yeah, no, plug in an x value of 2, it should say negative 70. Right, that's the way you can check. Always a good idea to check stuff. As soon as you write a line, especially if you factor something, as 5 or 6 of you are going to discover when you look at it. Because I said, what does this expand to? And when you expand it back out and then look at what it was supposed to be, you're going to go, well, that was dumb. Right? And I lost a half a mark because I went the wrong way, right? Like doing that, looking at that, because you know the number 2 is involved, and so you just throw a as negative 2, and actually it's negative a half. A cubic polynomial function. Okay, figure this out. You can do it. So here, start as it's cubic, so it's of degree 3. And they tell you something. Okay, so start with that, right? You're just saying, this is what I know. I know it is of the form y equals a. And I got to fill this in, and this. Plug in my x's and y's, whatever I know. Solve for a, and then rewrite the equation at the bottom where it's y equals, and instead of a, you've got the value for a, right? Whatever that may be. I think I could have boxed around this. I don't remember. Oh, I moved the thing. Great. So I'm pretty sure it starts like that. Okay, so that seems to match up with most of the words that are on there. But window-wise, let's cut her down. Say 1, 2, 3, 4, 5. Let's do that. So from negative 2 to 5. Let's go up here. Ones are not good. Let's try graph. All right, that looks like a half. It's passing straight through, right? So 1/2 multiplicity of 1, or sorry, negative a half. Y-intercept at 36. Second calc value when it's 0. 36. Yep. And what else? Touches the x-axis at 3. 2, 3. Okay, good. There's all my characteristics, right? I now know this is correct. Or I messed up really creatively. Kind of hard to get back. Algebraic determine the factored form of the equation of the polynomial function shown. You can read. Okay, so what are we going to do? Factored form. So we got to find the zeros, right? We're going to find the zeros. As we find them, we're going to say what's the minimum multiplicity for this zero. We're going to write them down, right? So we're going to write y equals. And we're going to find the first zero, and we're going to turn that into a... Okay, so what do we got here? So that's negative 1/2. So we got x is equal to negative 3/2. The multiplicity of 1. So you look along here, you say, okay, I got x is negative 3/2 with a multiplicity of 1. My factor is going to be 2x plus 3. Okay, we've got x equals 0 with a multiplicity of doing this. It's cutting through though, so it's 3. And then we've got x equals 1. Oh wait, so the factor is x. It's got a factor. This factor is x. Well, actually it'd be x cubed, right? That's an x cubed. That's a 2x plus 3 to the 1. That's an x cubed, and this is, the 0 is, x is equal to 1, the factor is, the multiplicity is 2. Okay, so we got multiplicity 2. So I've got, here are my zeros, along with multiplicities written with them. Here are my factors. I'm just going to put the factors down. So we've got x cubed, and we've got a 2x plus 3, and we've got an x minus 1 quantity squared. So it's of degree, what degree is it? 6. Okay, wait, I'm missing a little something here. Right? Let's toss this in. It should be y equals a. So I know it opens down. I know that a has to be negative. Now, is there any point on there I can use to help me find the value for a? So is it passing through any point whose coordinates we can very easily see? Like this point here. So I know negative 1, 8 is on here. So if I put in what for y? 8, and I put in what for x? Negative 1. So negative 1. So this is 2 times negative 1 plus 3, which I think is 1. And this is negative 1 minus 1, which is negative 2 squared, which is 4. So I've got 8 is negative 4a. So a is negative 2. So it's negative 2. Negative 2x cubed times 2x plus 3. Okay. So if you graph that, it should look a lot like that. And then if you go second calc value and toss in a negative 1, you should get an 8. If you find the maxima, it's probably a smidge over 10 and somewhere between negative 1 and negative 3. Like, I wouldn't bother looking for that necessarily, but it should look like that graph. To make it look like that graph, set your window to these values. Okay, like if you are planning to graph it, set your window to go here to here, here to here, and you'll look at it. Yeah, it looks right. Okay, then to double check, if you want to, throw in second calc value x is negative 1, see if you get an 8 out of it.
When we're writing the final equation, is there an order that you want the exponents from largest to smallest?
Oh, yeah, I suppose you could do that, but it doesn't matter. I'll take anything. Like the x cubed, so it should be positive or negative sign. So negative sign number x that's by itself. X cubed, x squared, just plain old x. The other guys, whatever order. Okay, but like don't write 2x plus 3 and then throw an x cubed in there. It's awkward. If you do, stick it in brackets. Okay, so it's less awkward. It just looks really awkward. But if I see something like this, it doesn't look right. Okay, you want to make it look right. It still doesn't look good, but it's better, right? Because then the x cubed at least is not. Right? Otherwise, I know you look at it and you start to confuse yourself. Think back to yesterday when you were confusing yourself on something, right? So everybody was looking at something and, you know. Exercise. So who do you think those are for? They're for you. So, let's move on. Because tomorrow's a short day, pep rally, right? So, we're just going to do... Whoops. Long division. What is that, grade 4 or something? When do you do long division? Grade 3? 4? I had no idea. I never helped my kid in math in elementary school. I never helped her in calculus either. So.
I just remember something like this.
Okay, so the long division algorithm passed down through the ages from generation to generation and no longer used much now other than in grade 3 when we teach you to do it because you have these things called calculators. But way back when you would have done 7 goes into 80, right? And you would say 7 goes into 8 how many times? Once. And 1 times 7 is 7. And 8 minus 7 is 1. And then we, come on, bring down the 0, right? And then we say, well, 7 doesn't go. So 7 goes into 10 how many times? Once. And then 1 times 7 is 7. And 10 minus 7 is 3. And so we have what? Well, we can write this a couple of different ways, right? We can say that 80 divided by 7. So it says express as a mixed number, right? So it'll be 11 plus, well, we don't even, the plus is implied, 11 and 3, what? 3 of these, right? 3 sevenths. So it's 11 and 3 sevenths. Is that true? Where's my calculator? I need a calculator to do fractions and mixed numbers. And how do you do those? So I've got 80 divided by 7. That's not even an 80. I've got 80 by 7, and I'm going to do this fancy. So I want the UND. Ah, wait, that makes me do it. Hang on. So let's do this. I want, nope. Okay, I want alpha y equals, okay, I want number 1, numerator and denominator, 80 over 7. Never mind, see, calculators are useless for these things. So there you go, it's 11 and 3 sevenths, right? Another way to say that is, slightly different way, you can say 80 is equal to 7 times 11 plus 3. Right? This one we can just look at and say, yeah, that's right. 7 times 11 is 77 plus 3. Okay, let's try 1205 divided by 51. So 1205. Okay, so we know 51 doesn't go into 1 and it doesn't go into 12. So 51 goes into 120 how many times? 2 times. 2 times 51 is 102. 120 minus 102 is 18. And then we bring down the 5. 51 goes into 185. 3 times. 3. 3 times 51 is 153. 185 minus 150. By the way, in calculus, you're doing all this by hand, right? No calculators in calculus. So start doing the odd bit of arithmetic. Okay, what do we got? 32. So what do we say? 1205 over 51 is equal to 23 and 32 51ths. Okay, on the calculator, which I'm not going to pull out, having already embarrassed myself enough. If you typed in 23 plus 32 divided by 51 with math enter to put it, would go 1205 over 51. Right? How else could you write this? You could say 1205 is equal to the divisor, which is 51, times the quotient, which is 23, plus the remainder, which is 32, right? So if you did that on your calculator, it's got to work, right? Because, or this is wrong and nobody's pointed it out. So that's long division. Now, of course, it's grade 12 math 30-1, the penultimate course in math in high school. So we aren't going to leave it like that. Remember grade 4 or 3 wasn't like wonderful. Okay, so now we're going to do this. So we're going to run through the same process we've just done, but we're going to do it with variables. So this is called long division, right, with polynomials. So I'm going to say x plus 2 goes into x squared minus 5x plus 7. Now, obviously it's got variables, so we're going to have to modify things a little bit, but the idea is still the same. So, x goes into x squared how many times? X times. Okay, put an x there. Then we take the x. X times x plus 2 is, x times x is plus 2x. x squared minus x squared. Negative 5x minus 2x is? So negative 5 minus 2, negative 7. So minus 7x. What do we do with the 7? Bring it down. Plus 7. X goes into negative 7x how many times? Negative 7 times, right? You just take negative 7x divided by x, you get negative 7. So minus 7. Negative 7 times x plus 2 is? Negative 7x minus 14. Now, we made these guys the same, and these guys, we don't have to worry about it. Like negative 7 minus negative 7, negative 7 plus 7, right? That's gone. So what's 7 minus negative 14? Where the arithmetic skills start to fail. What's 7 minus negative 14? Okay, so if you weren't coming up with 21, then you need a little work on arithmetic, right? Or you're going to be hauling your calculator out to do this and punching in 7 minus. Yeah, which you have to. If you have to, do it. I mean, I'd rather, because you get this wrong, it just gets really messy. Okay, so when you have to do a long division and you do it wrong, then the question becomes, instead of like a nice, easy, hey, this worked out really nice question, it becomes extraordinarily ugly, and then you're in big trouble, right? Because then you're now spending 15 minutes where 5 would have done just fine. So, all right, so then we could write this the same way we wrote these two guys, right? So we could say this over this is equal to, so we could say, let's do it down here, I guess. X squared minus 5x plus 7 over x plus 2 is equal to, so how many times did it go in? Well, it's the divisor. Oh, sorry, it's x minus 7 is the number of times it went in, plus 21 over x plus 2. Right? And you look at that formula, that's like really ugly and messy, and so you say, hey, up here when we had that, we just multiplied everything by 7, right? Just got the 80, got 7 times 11, took out the 7 there. What if we just multiplied everything by x plus 2? Then this would become x squared minus 5x plus 7 is equal to x plus 2 times x minus 7 plus 21. And you could actually check that by going, okay, what do I get? I got x squared minus 7 plus 2 is minus 5x, yeah? Minus 14. Minus 14 plus 21 is plus 7. Hey, that actually works. Right? This is amazing. I can do long division with variables. So in general, what do we call this thing here? That which is dividing into something is called the, it's just a name, right? Divisor. The divisor is dividing into something that has a p, which could only be the word, which describes this unit very well, polynomials, right? So I'm dividing into a polynomial. There are extraordinarily few words starting with the letter Q, so this has to be quotient. And the only thing left over is the thing that's left over, which is the remainder. Good, right? Okay, and then we can write this two different ways. Right? We could say the polynomial divided by the divisor is the quotient plus the remainder over the divisor, which is ugly and confusing and all of that. Or the polynomial is the divisor times the quotient plus the remainder. Just take everything multiplied by this, right? Divisor times quotient the same way, plus remainder. Okay, shall we try one more? Let's. We have time, and then tomorrow we can relax a bit, or not. So I want to divide x minus 1 into x cubed plus 3x squared. Now I have a problem, right? I got no x term. But when I go on and multiplying, I end up with an x term. So I need a placeholder for the x. So I'm going to go plus no x's minus 6. right? Because when we subtract, it has to be a cubed under a cubed, a squared under a squared, right? And you'll see what happens as soon as we get a couple of lines in. So what's x cubed divided by x? X squared. What's x squared times x minus 1? Okay, now here's the arithmetic starting to kick back into gear. What's 3 minus negative 1? Thank you. Say 4, say 4. I'm sitting here. Say 4. Please say 4. 4 what? 4x squared. What do we do with the 0x? Bring it down. Plus 0x. Now you're going to see why it needs to be there. How many times does x go into 4x squared? 4 what? I mean, if I just put 4, that's going to be a 4x. I need it to be 4x squared, so it's 4x. What's 4x times x? Minus 4x. You see why we need that 0x? Because if we don't have it, if I just had here minus 6 and then brought down minus 6, you can't do that. So we need a placeholder, right? We need an x term, and if there is no x term, then we shall create an x term, which is just 0x. It's just a placeholder. What's 0 minus negative 4? Please say 4. Thank you. 4x. And what do we do with the, we drop down, bring down the minus 6. How many times does x go into 4x? Now we get to say 4. Okay, plus 4. Okay, what's 4 times x minus 1? 4x minus, not 1. 4x minus. This is not the test. You're not allowed to make that mistake again. You'll see. You'll see when you get it back and say, I didn't multiply that by 2. What's negative 6? Here's your big test. What's negative? Yeah. Okay. Yeah, you spoiled it. The rest of them we're just trying to hope somebody else answered it before. Don't call on me. Okay, there you go. So are we done? That's it, right? Because we've got our remainder. Okay, so then what could we say about this? We could say the ugly thing, which is x cubed plus 3x squared minus 6 over x minus 1 is equal to x squared plus 4x plus 4 plus, I guess it's going to be minus 2 over x minus 1. Or we could say the pretty thing, which is x cubed plus 3x squared minus 6 is equal to x minus 1 times x squared plus 4x plus 4 minus 2. Now, if you want to know if I've done this half right, let's just get the constant term, right? Negative 1 times 4 is negative 4, minus 2, that's going to be my negative 6. Okay. The rest of it's going to multiply out properly. Okay. But you could check this simply by expanding. You're going to get here's a way to expand this and check it at the same time, but not the way you normally multiply. But I would just do this: x cubed, yep, plus 4x squared minus 1x squared. Right. So I'm going to do my x squared. So plus 4x squared minus 1 is plus 3x squared. Now I'm going to do my x's. Plus 4x minus 4x, 0x, minus 4. Minus 2, minus 6. See? That's the way I check that, is instead of writing it out as the 16 different terms or whatever, I'm going to collect my terms as I go along. That's not the normal way I would multiply that, right? But it's how I would do this. Okay, here we go. This is the big thing. Synthetic division, right? In other words, if you look up here, what's happening? We're making an x squared. We make an x cubed. And then we make the 4x squared. And then we make the 4x, right? So we can flatten all of this, right? Because I don't really need that. So here's what we do. We say, here's my x minus 1. Now you say, what weird symbol is this? This is the divisor box, okay? And instead of putting x cubed, I'm going to put just the coefficients. Because I only care about the numbers, right? This is a 1. 1x cubed, 3x squared. How many x's? 0 x's, and then I've got negative 6. Okay. Now, you can read that by simply saying that's the constant, that's the x term, this is x squared. Like, just start here. This is 0, degree 1, degree 2, degree 3. So this is x cubed plus 3x squared minus 6. Exactly what that says there. Okay, now here's what you do. A lot of times they won't write that x minus 1, but here's what you do. You bring down the 1. Okay? Because whatever number was there, 1, that's the number you want under here, right? If there was a 5 there, we would have put a 5. Okay, so you just bring down that number. And now, you go negative 1 times 1 is negative 1, and 3 minus negative 1 is 4, and negative 1 times 4 is, and 0 minus negative 4 is 4, and negative 1 times 4 is, and negative 6 minus negative 4 is negative 2. So here's how you read this. That's your remainder. That's your constant, that's your x squared. Right? If you're dividing an x cubed by an x, then your highest term is going to be x squared, right? So this is your x squared term, this is your x term, this is your constant, and that's your remainder. So then we can say x cubed plus 3x squared minus 6 is equal to x minus 1 times x squared plus 4x plus 4 with the remainder minus 2, right? Minus 2. Which looks a lot like that, but took a lot less work, right? Because really, we don't need to worry about this constant bringing down stuff, right? So this is called synthetic division, shortcut. Yes, you're going to have to practice a lot before you do that. You want to write like just x plus 1? Okay, there's an alternate form of synthetic division where you add instead of subtract. I'm not going to show it to you. You can learn it on your own. Actually, if you Google synthetic division, you're probably going to find ones where they do that. But the thing is, you got to change this. Instead of x minus 1, you got to go x plus 1. And it's really synthetic substitution. It's not really synthetic division. So ultimately, here's how it works. I give you this. I expect you to be able to divide it and get the remainder. Algebraically, show me some method, right? I'm looking here. I don't care what you put there. If this is right, life is good. If it's wrong, you lose all the marks. If you don't do it my way, you're going to lose all the marks because I can't just say, oh, look, that should be a negative. And again, this is checkable, right? How do you check, right? X cubed, yep. Plus 4x squared minus x squared. Plus 3x squared. Plus 4x minus 4x. No x's. Minus 4 minus 2. Minus. How long did that take? Not long. So if you get it wrong, you should know pretty quickly, oops, made a mistake. Must fix. Okay, got a sign wrong.